How does Node.js handle asynchronous code execution? Have you ever wondered how Node.js manages to juggle multiple tasks at once without breaking a sweat? Let's break down the fascinating process behind asynchronous code execution in Node.js. At the heart of Node.js is something called the event loop. This is a clever mechanism that allows Node.js to keep track of various tasks without waiting for each one to finish before moving on to the next. Imagine you are at a restaurant, placing an order, and then moving on to chat with friends while waiting for your meal. That's how Node.js operates with its tasks. When Node.js encounters an asynchronous operation, like fetching data from a database or making a network request, it kicks off that operation and immediately continues executing other code. It doesn't sit idle, waiting for the operation to finish. Once the operation is complete, a callback function is queued up to be executed when the event loop gets to it. The event loop works in a series of phases. First, there is the timers phase, where it executes any callbacks that were scheduled with functions like setTimeout and setInterval. Next comes the input-output callbacks phase, which handles the callbacks from completed input-output operations, such as reading files or querying databases. Then we have the poll phase, where the event loop waits for new input-output events and executes their callbacks. After that is the check phase, which runs callbacks scheduled with setImmediate. Finally, the close callbacks phase deals with events like closing sockets. This structured cycle allows Node.js to efficiently manage many tasks at once without blocking the main thread. To help with this, Node.js uses a library called Libuv, which handles the event loop and manages input-output operations at a lower system level. This means that slow operations, like accessing the disk or network, can be offloaded to the system kernel or a thread pool, allowing the main thread to keep working on other tasks. When it comes to handling the results of asynchronous operations, Node.js offers several options. You can use callbacks, which are functions that run once the operation is done. Promises are another option, representing the eventual outcome of an asynchronous operation and allowing for better error handling. Lastly, there is the async await syntax, which lets you write asynchronous code in a way that looks synchronous, making it easier to read and maintain. This asynchronous model is especially useful for backend development. It allows Node.js servers to handle many requests at the same time without getting stuck on slow operations like database queries or API calls. This leads to better scalability and responsiveness, which are essential for applications that rely on server-side logic. Even though Node.js runs JavaScript in a single thread, it can delegate heavy tasks to worker threads. This keeps the event loop running smoothly, ensuring that asynchronous operations are handled efficiently alongside demanding computations. In essence, Node.js manages asynchronous code execution through its event loop, which organizes non-blocking operations effectively. By utilizing Libuv for system-level input-output and providing various programming patterns, Node.js makes it easy to write clear and maintainable asynchronous code. This approach is what makes back-end development with Node.js both accessible and straightforward, particularly when building APIs or managing databases.